Hi, we are going to talk today about constructing an angle bisector. So in a similar way that I've done constructions in a past video, you can follow along on the notes step by step. You can use a real compass and straight edge if you would like. Or you can follow along with me in GeoGebra. So let me change to my GeoGebra screen. And so this time we're going to construct a bisector of an angle, similar to a bisector of a line segment. We are going to divide this angle in half. So let me start by constructing an angle. And in this case, I'm actually going to start by making a circle. And the reason is because I want the points on my angle to be connected to this circle so that I can drag it around and try lots of different options here. So I'm going to construct a circle, and then I'm going to choose the ray tool and draw a ray starting at A and going through point B on the edge of the circle. I'm going to construct another ray starting at A and going through any other point on the circle. You can pick where you want it to be. And it honestly doesn't matter, because as you see, if I drag this around, now I can move my angles and I can change the size of my circle to any size that I want. And all of these points are connected to each other. Okay, so let me just move it so that you can see it a little bit better right here. Now, I can measure the angle that is made by, whoops, I did it backwards again. So I can measure string C, A, B, and we can see that my angle right now at this position is 38.6. That's kind of an ugly number. So I'm going to change that number. I'm going to move my angle around a little bit so I get a nice pretty number. Like if I can get it to 50, I will. Very close to 50. Oh, 48. Whoops. And then I took my finger off of the screen. So let me see if I can get it back to somewhere close to a nice even number. 50 degrees. Yay. So basically, I'm doing that so that you can see that when I construct my angle bisector and I measure each individual angle, that I should get each angle equal to 25 degrees, because that means that I split my angle exactly in half. So let's see how we do that now. Now I'm going to go down here to my compass tool. We used that in a previous video. So I'm going to construct a circle with a radius from B to A and a center at B. Okay, so my radius is this distance from B to A, and my center is at B. I'm going to do the same thing and construct another circle, distance C to A. And we already know that because they are both radii of circle A, that they have the same distance. So both of these circles are going to have the same radius. And this time my center is at C. Okay, so now I've got basically 3 circles that are the same size. Okay, but one has a center at A, One has a center at B, one has a center at C. And now I've got this overlap, just like we kind of had with the perpendicular bisector. So now I'm going to take my ray tool. I'm going to start at A, that's our vertex of our angle. And I'm going to plot another point here. It's going to say D, doesn't matter if yours says another letter, it's okay. But now this should be a bisector of this angle because we've got circles that are intersecting with the same radius. Okay, let's test it out. And I'm going to measure this angle from D to A to B. 25 degrees. Hallelujah. That's what I wanted to see, right? Because my original angle was 50 and I want it to be half. So that should mean that the other one is 25 also, but I'm going to measure it just to be sure. Great. The other neat thing about using GeoGebra is that I can now move my circles around, just like I was doing before. And you can see here that no matter what I do, both of those angles are the same. And if you add them up, they become the total angle here. So I'm always going to have an angle bisector no matter what I do and drag it around. So try this out on your own and let me know if you have any questions.